Hello everyone, yes I'm Fraser, thanks for coming to watch me say things. Just turn my clicker on and get straight into it, because 30 minutes is not much time to cover all of this stuff, but I just drank a Red Bull, so let's roll. So this is a talk about the little green padlock. I think everyone or almost everyone in this room will understand that this little green padlock is very, very important for the security of the internet and the security of all of us as people and as members of society. If the little green padlock isn't there, depending on what you're doing, that's just not a good situation to be in. But unfortunately, even if the little green padlock is there, it doesn't mean that all is as it should be. So in this talk, we're going to very quickly recap, if necessary, how the public key infrastructure used to secure the web and some other internet communications actually works. And we'll look at a couple of incidents that have occurred over the last couple of years where things went very badly for a couple of CAs. By no means an exhaustive list, but just some of the more prominent occurrences. We'll then switch to more positive topics and look at some of the efforts currently underway to make things less terrible, and I'll conclude with a few suggestions about what you can do if you're deploying TLS to be more secure, for your customers to be more secure. So just raise your hand if you're in this room and you do not have a passing familiarity with digital certificates, TLS, certificate authorities. Awesome, I can skip this slide. But for the benefit of anyone watching the recording, basically the protocol we use to secure HTTP and some other internet protocols is called TLS, Transport Layer Security. Previous versions were called Secure Sockets Layer, SSL. In this protocol, a server presents a certificate. That certificate has been issued by a certificate authority, of which there are myriad, and this is normally done for a fee, usually quite a significant fee. The certificate has a defined lifetime, and it binds the server's public key to a domain name, which is included on the certificate. So as part of the TLS handshake establishing this secure channel, the server presents its certificate, and a client will validate that certificate using a store of trusted CAs, so root certificates. It makes sure that there's a path of validity from one of the CAs that it trusts down to the server's certificate, and it also checks that the certificate is valid in terms of its validity period, and makes sure that the domain on the certificate matches the domain name that the server thought it was connecting to. So that's a very high-level overview of how that all works using public key cryptography. So if that checks out, everything's all good, right? Yeah. One of the big problems we have is that there are literally hundreds of CAs. If you go into your browser or your operating system certificate store and have a look at your root CAs, I stopped counting after 100, and I was only a quarter of the way through the list, something like that. There's just so many CAs. I don't mean to pick on the Hong Kong post office, because there are lots of examples of CAs in this list that you think, why are they in there? Yeah, Shanghai Digital, I mean, they probably issue certificates, but I don't know if I've ever visited a website that presented a certificate signed by the Hong Kong Post. Or if I did, maybe that would be something to look into. I'm not sure. There's just no way that we can actually audit all of these certificate authorities properly, and there's actually no need to have hundreds of certificate authorities all in commercial competition with each other, issuing random-looking bit strings to certify websites or certify domain names. We've seen many instances over the years of CAs who have had their infrastructure hijacked, like DigiNotar, which was a Dutch CA, or who have misissued certificates And part of the problem is that there are just so many, and we can't possibly audit them correctly. And they're all in commercial competition with each other, so the financial incentives involved militate against disclosure of issues when there are problems, because as a certificate authority, if you discover that your infrastructure has been hijacked or you've misissued certificates, from a financial point of view, you might want to sweep that under the carpet, because if people don't trust you, the root CA, you're basically dead in the water. Customers will go somewhere else. Browsers will remove you from the trust store, and that's it. That's the end of you. So, when I submitted the abstract for this talk, I described the CA industry as a dumpster fire, but on reflection, that's not a good analogy. Dumpster fires certainly are spectacular, but they're also pretty easy and pretty quick to extinguish. You just fill it up with foam and water, and then the cleanup begins. What we have in the CA industry is a protracted, economically and ecologically devastating, ongoing issue, where the acute effects are not always apparent, but sometimes the ground can collapse underneath you and you have a very bad day. And so we're going to look at a couple of examples where this happened over the last couple of years. So the first one is WoSign, and WoSign's woes begin in 2016 when they were caught out backdating certificates using the SHA-1 algorithm. So the background here is that SHA-1 had been considered by cryptanalysts for some time to be on the verge of being broken. So basically it was considered no longer secure, no longer state-of-the-art crypto. We should be moving away from it. This happened over the course of a couple of years in terms of deprecations and implementation periods to move away from SHA-1. And the CAs were in agreement with this, but they just needed time to do it and time to get their customers off SHA-1 and onto SHA-256. And so the rule that everyone agreed was SHA-1 certificates will be prohibited after 1st of January 2016. That is to say, a CA issuing a SHA-1 certificate after that date has done the wrong thing, has been very naughty, and is subject to being distrusted by browsers. Nevertheless, a lot of customers out there hadn't moved quickly enough or had stuff deployed that they couldn't update, and they still wanted SHA-1 certificates. Now that's a customer problem, and is a problem for CAs when customers are coming to them saying, we want to give you money and we want you to give us a SHA-1 cert, even though you're not supposed to. WoSign got caught out doing this, but they were backdating the certificates. There was some strong cryptographic evidence that they were doing this and a volume of circumstantial evidence. One particular aspect of that was they had issued a bunch of certificates using the SHA-1 algorithm on the not at all suspicious date of 31st of December 2015, which I think was a Sunday or a Saturday weekend. So yeah, that was just one aspect of a whole list of circumstantial facts that basically added up to WoSign having done this despite their denials. There were also a number of other issues with WoSign, including their failure to disclose the purchase of Startcom, an Israeli CA, which they also denied, but again, the facts said otherwise. And they were also putting unvalidated information in the subject name of the certificates they were issuing, or some of the certs they were issuing. So everything that goes into the subject distinguished name in a certificate is supposed to be information validated as correct by the certificate authority. But WoSign decided to put ads in there, so yeah. Just crazy stuff, right? So the consequences for WoSign is that now they've actually been distrusted by all of the browsers and root store operators. Distrusted in the sense that any new certificates they issue after a particular date won't be trusted. Old ones are still being trusted, with the caveat that if they observe any more shenanigans, like backdating certs, from WoSign, they'll just remove their certificate from the root certificate store entirely, and anything they ever issued will no longer be trusted. But suffice to say that they're dead in the water right now. They're gone because of what they tried to pull. So in the end, a good outcome, but the fact that this stuff is happening, and this is just one CA that we know has been doing these things. Who knows how many more there are out there. So another CA that got up to a bit of, well, if not mischief, then mishap, was Symantec. So in late 2015, Google observed a certificate issued by Symantec, or a couple of certificates issued by Symantec for google.com and www.google.com that they had not authorized. So this was concerning. Google went to Symantec with a please explain, please revoke these certificates and go and perform an audit and try and work out how the heck this happened, because this should not have happened. So Symantec revoked the cert and they went and they ran an audit. And a little while later they came back and said, mea culpa. Some engineers were doing some tests of the infrastructure and they issued a bunch of certs that they shouldn't have, and we identified 23 certificates. And Google said, okay, thanks for doing that. And then they went out to corroborate this number of 23 misissued certificates and found another 2,000 and something misissued certificates, including 164 which were for registered domain names, and 2,400 and something which were for domain names that at that time were not registered. So what we thought was a bad situation already was actually much, much worse. So they went to Symantec again, basically said, well, this is unacceptable. We're going to require you to log all certificates you issue, not just EV certs, which they were already required to do as part of the EV requirements. EV is extended validation. But all certificates you issue, we now require you to log. I'll talk a little bit about that shortly. And bring in an external auditor, because this has been a major issue. Find out what's going on, put something in place to prevent it from happening again. So they got the audit. They came back after a while and said, look, we've had a full audit, we fired a bunch of people, we've put in a whole bunch of controls and processes to make sure that this never happens again. And then in January 2017, so last month, a researcher identified another 108 misissued certificates from Symantec that had been issued throughout 2016 and early 2017. So much for firing a bunch of people and those new controls. So the fact that a CA, a very prominent CA issuing a lot of certificates, was initially unable to determine the scope of a problem they had, and then came back and said, we fixed it, it's not going to happen again, but it's still happening, is very poor. And this is one of the most closely watched CAs, one of the biggest CAs out there that people are paying the most attention to. So if you extrapolate that out, the situation is not good. What happens next for Symantec, we don't really know. They are one of the biggest CAs, so the idea of distrusting them is frankly unpalatable. I mean, I don't think in the long term it would be a good thing. I do think that it may be a good thing in the long term, but in the short term, to just do that would be pretty crazy. So exactly what's going to happen next, I don't know. Watch this space. So on to happier topics. Let's talk about Let's Encrypt. So who here is using Let's Encrypt today? And that's about a quarter of the people in the room, which is pretty good. So Let's Encrypt is a free, publicly trusted, automated CA. It's run by the Internet Security Research Group. That's just a legal entity behind it. It came as a collaboration of the EFF, Mozilla, Akamai, IdenTrust, which is one of the sort of existing incumbent CAs, and someone else, I forget who, Anyway, there was another organisation as one of the founding members, and since then a whole bunch of other sponsors have come on board. They only offer domain validation certificates, and I think this is actually fine. EV doesn't actually bring a lot extra to the table in terms of making end users more secure. Most people aren't going to look at the certificate information, they're just going to care, can I connect to this website or not? And hope that the public key infrastructure being used to secure the connections and authenticate the endpoints is doing its job properly. So EV, in my opinion, is just a shakedown and doesn't actually bring anything to the table in terms of making people more secure. The way Let's Encrypt works is it uses a protocol called ACME, which when you want a certificate, you register with the certificate authority. Clients do this automatically. And you say, I want a cert for this domain name. The server sends some challenges that you have to respond to in order to prove your control of the domain name that you want the certs for. And if you can satisfy those challenges, then the server will issue you a certificate. In a nutshell, that's how it works. Standard certificate lifetime is 90 days, and the idea is that it's all automated. So if you're running an HTTP server, you already have the DNS pointing at your domain name, so proving control of the domain is something that can be automated. It should be automated. Let's Encrypt and some other organizations have been building tools to automate it, and they're the CA that offers this protocol. So it's a great initiative. And they went live in November 2015, and awesomeness has occurred ever since. So this is a chart of the growth of Let's Encrypt. So they've gone live here in November 2015, and you can see they're hockey sticking, basically currently about 29 million active certs, so that means non-revoked and non-expired, covering 28 point something million fully qualified domain names, and you would expect those numbers to be fairly similar. And the number of registered domain names involved is 13 point something million. This chart is just from a few days ago at let'sencrypt.org/stats. So amazing growth. In fact, they're currently the third largest CA by the number of certs issued after 1 year. These facts came out of a paper that was released in December, looking at the certs that had been issued by Let's Encrypt and drawing conclusions about the impact of Let's Encrypt from that data. Fascinatingly, 93% of the domains that Let's Encrypt has issued certs for had never previously had a certificate issued for them. Assuming those certificates are being deployed, of 13 million domains, that's 12 million domains that previously had no authentication, no encryption, and now these sites are encrypted, and when you visit them, you can't be man in the middle, assuming something else has not gone terribly awry, like they've let their public keys out into their private keys out into the wild. So anyway, if we make that assumption, that's a pretty amazing impact. Interestingly, about half the certs issued by Let's Encrypt have been issued to a handful of service providers like WordPress, OVH, who are a cloud provider, and Shopify, some sort of e-commerce provider. I don't know exactly what they do. But people come to them, bring their own domain names, and these hosting providers host services for those people. And that's basically all you need in order to execute ACME and automatically get a cert for them. So if you are Bob's Widgets and you have a blog on WordPress, bobswidgets.com, you just go to them automatically as part of the base offering, you just get TLS without even asking for it. This is really where we wanted to get to in terms of hosting providers, software as a service, platform as a service. If you work somewhere where you're building these offerings for the public, make Let's Encrypt part of your base offering, because it makes your customers' lives much easier, and it means that they just get TLS for their services out of the box. Page loads have gone in November 2015 from about 40% of all page loads in Firefox being done over HTTPS to 50% in 1 year. We've had HTTPS for 20 years, and we'd only reached 40%. And keep in mind, a significant amount of that 40% are going to be heavily frequented properties like Google, Facebook, big e-commerce sites, online stores. So I don't know what the numbers would be, but maybe half of that is just that stuff. And then another half. So maybe, I'm just pulling this number out of my ass, but maybe there's been something like 50% growth, excluding those big internet companies, in the number of sites using TLS over the last year. This is not all attributable to Let's Encrypt, but a substantial amount will be the result of Let's Encrypt. That's pretty awesome. So what do the incumbent CAs do in the face of this sort of disruption? Hilarious things is what. Komodo are one of the large CAs. They decided to register the Let's Encrypt trademark, as I had 3 trademark applications for Let's Encrypt. So they filed these in October 2015. The ISRG had been using the Let's Encrypt brand since 2014, and for 3 months from March last year, they were engaging Komodo privately over this matter and getting nowhere. And so in June 23rd, they posted a blog post basically saying, look, this is what's happening. We need to defend our brand. We've had no luck talking behind closed doors to Komodo, so we're just putting it out there. This is what's going on. The internet exploded, and on June 24th, they filed for express abandonment of their trademark applications. So that's a good outcome. Also, their CEO went on their message boards and posted a bunch of rants and FUD about Let's Encrypt, saying, well, you know, they're not a managed service, they can't revoke certs, which is not true. They can, and they have. And you know, they clearly wanted to leverage the market of free SSL users we helped create. It's like, oh, they've stolen our not customers who aren't paying us. Yeah, work that one out. It makes for good reading. The link's there. I've got a link to my slides at the end of my talk. You can follow up on any of the footnotes later on. StartCom, again. So yeah, they had lots of shenanigans last year. They announced Start Encrypt in June last year, which was designed to be approximately the same thing as what Let's Encrypt is, so an automated CA. They built it all themselves, all custom, all proprietary. You just get a binary client, and it can integrate with your web server, and you run it, and a cert comes out. It was full of security holes. The worst one was that it was a client-controlled HTTP post parameter telling the Start Encrypt server where to look on the destination server for the proof of control of the domain. So if you use any website where you can post content and that content can be displayed back in raw form, like GitHub, for example, then you could use Start Encrypt to get a valid TLS certificate for github.com or whatever site you were using. So that was pretty bad. And yeah, again, the link is not here, but go look at my slides. There's a link to a post about it that enumerates the several issues. They also wrote the private keys that they generated world readable and writable. So, you know, it was just, they got laughed off the internet for a month, and then they said, okay, we'll abandon it. We want to offer something here. We're going to start again, and we're going to use Acme, which is really where they should have started. A couple of the other firefighting efforts that are currently underway. Certificate transparency. So I mentioned earlier about logging certificates. I also mentioned that, for example, Google observing that some certificates had been issued that shouldn't have been. Certificate transparency is the technology used to do that. So basically it's an append-only, immutable, cryptographically strong log of observed certificates. Anyone can submit them. You only have to be submitting a cert that chains up to some well-known, publicly trusted CA. The idea is that certificate authorities will log all certificates they issue through their infrastructure. This allows domain owners to monitor the logs for issuances of certificates covering their domains that may not have been authorized. and it allows certificate authorities themselves to compare, for example, business events against issuance events and try and determine if their infrastructure has gone haywire or has been hijacked. So basically, it's a canary in the coal mine. Gives you an early warning of when something that shouldn't have happened has happened and something needs to be done about it. Another animal that's here to help is the Great Dane. So Dane is DNS-based authentication of named entities. The idea of Dane is that as a domain owner, you can put into DNS records that basically say what keys, so key fingerprints or certificate fingerprints are valid for a particular domain. So it's putting the certification of keys back into the hands of the domain administrator instead of in the hands of one of myriad third parties doing it for a fee and being difficult to audit. So if you think of CAs as a bunch of deck chairs on the Titanic, basically you are making a trade-off with Dane, and also there's the caveat that DNSSEC is hardly deployed anywhere, and I've never deployed it, but people who have tell me it's a shit show. But the concept is sound, and I love the concept, but the trade-off you're making is instead of one of myriad CAs that could potentially go rogue, you're putting all of your trust in the DNSSEC root key and the intermediate keys. So instead of deck chairs on the Titanic, it's like it is the Titanic, but actually it's got 7 hulls and 7 captains all doing their job properly, and it's more auditable. So yeah, you just got to be aware of the trade-offs you're making if you adopt a technology like Dane. Browser and root store operators are flexing their muscle. So they're distrusting CAs that do the wrong thing, including WoSign. This has not happened enough. They're starting to require certificate transparency for all issued certs. Currently that's required for EV certs. But in October, Chrome is going to start requiring it for all certificates, and other browsers will probably follow suit. Certainly I expect Mozilla will.
So Fraser, I've got a very quick question for you. With the Let's Encrypt, do they export everything already through the certificate transparency?
They log everything to CT. A lot of CAs already are. This is just saying for all CAs, if you want us to keep trusting you, you have to log everything into certificate transparency. So a lot of CAs are already doing that. And that's that research paper from December last year about the stats of Let's Encrypt. They actually scanned the certificate transparency logs to look at all the certificates they'd issued. So you can do all kinds of useful, not just for security reasons, but for statistical reasons. Examining what's in the logs can be quite an interesting exercise. Browser vendors were pushing to limit certificate lifetimes to 13 months. There's a vote going on in the CA browser forum right now on this ballot. It's not going to pass. I checked last night. Most of the browsers have voted in favour for it. One CA has voted in favour. Guess which one? Let's Encrypt. They're issuing certs already that are maximum lifetime 90 days, so it's no problem for them. All CAs have voted no, except for Swiss Sign, I think, who voted abstain. And one CA said that they agree with reducing the lifetime to 1 year or 13 months, but they did not agree with the implementation period of actually making this change. So basically it's not going to pass, which is a shame, but nevertheless the browsers are pushing in that direction. Some of the CAs, quite a number actually, came out and said, look, we think 24 months is a better next step over the current maximum lifetime of 39 months or 3 years. So yeah, they're pushing. It's not going to happen right now, but watch this space. I expect we'll see another ballot for 24 months or something down the track. If you are deploying TLS, consider using Let's Encrypt today and automating that part of your infrastructure. Use strict transport security to make sure that anyone who visits your site over HTTPS never again connects using raw HTTP. This is a trust on first use technology, but all the browsers offer a preload program where you can add your domain to a list that makes sure that clients will only ever connect over HTTPS to your website. Public key pinning goes a step further, and it actually caches the certificate keys that are used, or the CA's keys, so that on future connections, if the keys have changed or if the CA's keys have changed, that's indicative that a misissuance has occurred and your browser's going to freak out and not connect. And again, there's a preload program offered there. You should monitor certificate transparency logs for your domains to detect misissuance, and you should deploy DNSSEC if that's something relevant to your organization, and prepare for technologies like Dane. You can also put SSH host key fingerprints into DNSSEC, and your users can avoid the whole do you trust this key, and they see a key fingerprint. That whole problem just goes away because the client can check the DNS records and see, yes, it's valid, connect. Or no, it's not, don't connect. So good usability wins there as well as security. That's the end of my talk. Is there time for questions?